Okay, now this is going into channel 1 of the oscilloscope. The oscilloscope is basically a voltmeter, and it, instead of moving a needle or giving a digital readout like an ordinary voltmeter, what it does is it essentially plots a graph of voltage on the y-axis versus time on the x-axis. So let me turn on my power supply here. I've got it set to put out about 750 hertz, and I can see the sine wave here on the scale. Now, these two sets of controls that are marked vertical control the y-axis of our graph here. These, there are actually two separate input channels. Right now we're just looking at channel 1. This knob, the one that's marked volts per division, sets the scale of the y-axis. So I can make the signal larger or smaller. If I make it too big, it's kind of hard to see. All I'm seeing is vertical lines. So in a case like that, just simply turn it back down until you can see the signal. This one over here, this set of controls marked horizontal, controls the x-axis, which is time. And so when I change the seconds per division, it lets me see more cycles or fewer cycles. Now, all of these have position knobs. In the horizontal case, it'll move the signal left and right. In the vertical case, it'll move the signal up or down. There's a number and an arrow, in this case number 1, and that tells us where the 0 point of the signal is. So a lot of times we'll want that set right on the x-axis so that the signal is centered on the screen. Now, there are a number of menus on here. For example, one of the most useful ones of all is the cursor menu. And if you push the cursor menu, you have two options. One is voltage and one is time. For example, if I set it on voltage, I get two horizontal cursors controlled by the position menu, the position knobs. So if I move this one up, say, to the very top of the wave, and the other one down to the very bottom of the wave, I get what's called the peak-to-peak amplitude. And if you look right here on the screen, there's a window marked delta, and that says the difference between those two cursors is 11 volts. If I change to time, it makes the cursors vertical. And let's say I put one of them, let me move my signal just a little bit. I'll put one of the cursors on this peak right here, and the other cursor on this peak over here. And the difference is 1.78 milliseconds. And the reciprocal of that, that's what this number below it is. It's simply the reciprocal of the time between the cursors. It says about 562 hertz, which is, my output over here says 560. So it's a reasonably accurate way to measure the period and then calculate the frequency of a signal. We do have a little problem in this laboratory. There's a radio station right over there pumping out about 90 megahertz RF signal, and it does cause a lot of noise in these signals here. shielded cables help a lot, but they don't completely eliminate it.